This is an example for section 1.3. So the example we want to do is we want to let f of x be negative 7x squared plus 1, and we'd like to use the limit definition of the derivative to compute f prime at negative 1, and we'd also like to describe what f prime of negative 1 means geometrically. So the limit definition of the derivative is the limit as h goes to 0 of f at negative 1 plus h minus f of negative 1 all over h. So here in my limit definition of the derivative, a is negative 1, since I'm computing the derivative at negative 1. So then I use function notation, and I have the limit as h goes to 0 of negative 7, negative 1 plus h quantity squared plus 1 minus negative 7 minus 1 squared plus 1. And this is all over h. Then I do some algebra. So I have the limit as h goes to 0 of negative 7 times the quantity 1 minus 2h plus h squared. So I FOILed that out, plus 1, minus, and then I cleaned up that last little bit, so I have a negative 6. So minus a negative 6 still all over h. And if I do some more algebra, so if I factor out or distribute through that negative 7, get negative 7 plus 14h minus 7h squared plus 1, and then my minus, a minus 6 was plus 6. Notice I have a minus 7 and plus 7, so those add up to 0. And what I have is the limit as h goes to 0 of negative 7h squared plus 14h all over h. And if I factor out an h from the numerator, I have h times negative 7h plus 14 all over h. I can do a careful cancel with those h's because I'm taking the limit as h goes to 0. So h is never equal to 0, so I'm okay to cancel those h's. And then I'm left with the limit as h goes to 0 of negative 7h plus 14. I try substitution to calculate that limit, and indeed I get an actual number, so I get 14 is my limit. So remember, my conclusion is that f prime of negative 1 equals 14. So the derivative at the point negative 1 is equal to 14. And geometrically, what does this mean? This means that the slope of the tangent line to f of x at x equals negative 1 is 14. So remember, the derivative at a point means slope of tangent line at that point. So if we want to look at this graphically, just to sort of give ourselves a check to see if our answer was reasonable, my function is a parabola facing down, and at negative 1, my tangent line looks awfully steep. So I can believe that the derivative there might be 14, so the slope of that line is 14. As an exercise, let f of x equal x squared, and I'd like you to use the limit definition to find f prime of 3.